Let's take a look at the algebraic steps to finding an inverse function. So you can find an inverse function from a table or coordinate points or a graph, but this video is only going to look at algebraically finding an inverse function. First thing I want to point out is an inverse function is this notation right here, inverse, so f little minus 1 x, that is not 1 over f of x. No, big no, that is not what that means. The little minus 1, you may remember from trig, means inverse. For example, the inverse of sine was written like this. That does not mean 1 over sine of x. Okay, just a little note right there. Let's say you have this function f of x equals 2x squared minus 3, and you're asked to find the inverse. Step 1, replace your f of x with y. So right here, instead of writing f of x, I'm just going to write a y. So I write y equals 2x squared minus 3. Easy. Step 2, we're going to swap x and y and solve for the new y. So I'm going to put x equals 2y squared minus 3. So what we've done is we've taken the output and we're making him the input, and we're taking the input and making him the output. So we're swapping outputs and in, and that's the definition of inverse. So your output becomes your input and vice versa. Now we got to solve for this new y right here. So now it's just algebra. I'm going to add 3 to both sides. I'm going to divide both sides by 2. X plus 3 over 2 is y squared. And then I need to square root both sides to get rid of the exponent of 2. And I have now x plus 3 over 2, quantity square rooted, is equal to y. I'm not finished yet until I write it in inverse notation. So the inverse notation is with the little minus 1, f minus 1 at the top there of x, the inverse of x, is the square root of x plus 3 over 2. If you want to write it with exponent notation, we have x plus 3 over 2 raised to the 1/2. There's your answer. Put a box on it. And if you were to graph this puppy, you would see that he would be symmetrical about the line of y equals x with this one. So let's just take a look at that real quick. Using my graphing calculator, I've graphed the parabola y equals 2x squared minus 3. And then I graph the inverse, and you can see that he has been turned sideways. If I graph y equals x, you can see that they are symmetrical about this line y equals x. So when I zoom in on this, you can see that every point over here has been reflected onto the inverse. So this was inverse of f of x. Here's f of x. And so it's when you're graphing these, it's really helpful to take points that you can identify. So this is a great point at 2, 5 right there. And then you switch him. So this point, if I write it down, is 2, 5. When you reflect him across the line, y equals x, you get his inverse, and he's going to be at 5, 2. And if you have a really great graph, you can do that with a lot of different points.